Let's talk about the flavor of the day, artificial intelligence. You've talked of data science. What are the mathematical underpinnings of today's AI world, and what can mathematics do for this whole field?
So, what mathematics can do for this whole field, but it's very far from clear how to do it, is to kind of understand, of course, what is happening. So, we are still at a stage now. I think we are at the stage where we were with natural science, classical science, maybe 1,000 years ago, where we could see something fall, but we don't know why it is falling. So, I think in the same way, I think we see these systems which are incredibly complicated, behaving in very, very uh, unpredictable but also very swimmingly intelligent ways based on the data they have ingested, but we really have no idea of knowing how they are going to work and how reliable they are. So I think the holy grail right now is to have a mathematical theory or some way of understanding how these systems evolve as they grow in terms of ingesting more data. But so that I would say is, of course, so a lot of mathematics goes into building these systems, and that is a very different kind of thing. But uh, I would say that in the last, my impression at least is in the last several, maybe 5-7 years, a lot of the advances in the AI models and all that has actually come more from experimentation than from theory, in the sense that people are designing new systems based on some instinct that maybe this will help, maybe that will help. So it's a bit like taking some engine and tweaking, turn this valve, turn that valve,
No,
and so on.
talk of engine. I'll have to interrupt you for just a minute. The steam engine was invented in the 1840s. A working model was realized, it was doing some things for people. But the laws of thermodynamics were written a clear 40, 50 years after the steam engine was working. I can see a parallel to this. Is one of my colleagues from Columbia, brought this out in a talk he gave. Um,
No, and I think that is very true. Similarly, I mean, electricity and Maxwell's equations are not, you don't need Maxwell's equations to have electricity, right? So the same way, I think AI has now reached that stage where people are, I would say, really it is still a very experimental science. That the unfortunate aspect of it is this is experimentation is very expensive, right? Both in terms of the computational power involved and in terms of the amount of data which needs to be ingested to check whether the experiment works or not. And that has made this whole thing a little bit unequal. I think that outside these large corporations, which includes Googles and Amazons and Metas of the world, even academic institutions in large, well funded academic institutions in places like the US struggle to have the kind of resources to do these experiments. So, really, it's become a situation where one small group of industries is really making decisions about which directions to move, and the rest of the people are trying to catch up in some sense. But I think from a mathematical point of view, I think it is really, but it's going to be it's not easy. I think it's going to be as complicated as anything that we have done in understanding any other kind of complex theory as to why these things work. And of course the other challenge is that we are no closer with all this AI models and all to understanding how actually our brain works, right? So neuroscience and computational AI are two very different beasts. So that is still a challenge, right? So we are not in a way we are not really capturing or even close to understanding our own thought processes. So it's not surprising that we are not able to actually get that right.
what I'm hearing you say is now is as good a time as any to be a theoretical computer scientist or a mathematician inclined to this set of problems. Um, and when we have written the laws of AI, so to say, what would that AI world look like? I'm sure it'll be less energy consuming, more orderly. What are we aspiring to do as a theoretical computer science community there?
So I think as a going back to what I said earlier, when you make complex systems, you need to, when you deploy them, and that is where really the challenge comes. See, so long as AI was a toy, which is a laboratory toy, it made no difference. But now if AI is ruling people's lives. It is making decisions about various things, innocuous decisions about what TV show to recommend to you, but also deciding, which resumes to shortlist or which loans to be sanctioned. And then at another level, how to navigate a car. You need to be clear why it is doing what it is doing and whether it's doing it right. Leave aside the other problems that we have, which is about fake news and influencing opinion manipulation, whether something which is being put out is actually real or whether it is being manipulated. So for all these things, I think we need to be able to have that clarity, right? So what is real, what is not real, what is the possible, what are the boundaries. So I think that is where we need to aim for. So a world where we understand these better is one where we can control it better. Say right now everybody's talking about regulation, but regulation is not possible unless you understand what you're regulating. And unfortunately, AI is not like something tangible like nuclear power, where you can say you cannot, store uranium, or you cannot. I mean, it's a very intangible resource. So how do you stop people from experimenting? You cannot. So at best, you can say, okay, when you deploy something in a public way, at least we can check whether it is doing what it's doing or not. That should be our. It's a very tall thing to reach, but I think we should aim for that.